Okay, question 9b. So for part 1, we need to find the expected number of cakes sold on a typical day, and we know that the probability a customer buys a cake is 0.45, and we're told that on a typical day there are 200 customers that come to the cafe. So then we're going to get 200, because there's 200 customers on a typical day, times the probability that they'll buy a cake, which is 0.45, and that is equal to 90. Okay, so that is 9b part 1. For 9b part 2, we need to find the probability that more than 100 cakes will be sold on a typical day. So the trick here is to see that we can use the binomial distribution. And that's because we've got a success or failure, with the success selling more than 100 cakes, and the failure would be selling 100 cakes or less. So then what we can say, well, if we let X be the number of customers who order cake, then we can say that X is binomially distributed and our number of trials is 200 and the probability for success is 0.45. So what we want to find then is the probability that X is greater than 100. So that's going to equal 1 minus the probability of X being less than or equal to 100. And we can use our calculator to solve this. So we'll bring up our calculator, and then we just need to plug our expression here in and work that out, and then we'll have our answer. So we'll just bring up a new calculator. Okay, so we've got 1 minus, and then we're going to go to probability, and then to distributions, and then we want the binomial CDF, this one here, the cumulative distribution function, and then we just plug in our numbers. So number of trials was 200, our probability of success was 0.45, our lower bound is 0, and our upper bound is 100. And working that out, we get 0.068075. So we just need to round that to 3 significant figures, and we're going to get 0.0681. And that is our answer for question 9b, part 2.